My maths equation paper by Tony Karachik. Can you give me the maths equation for the feedback loop frequency vibrational pattern with the value of Hertz 100? This is more to measure brain activity. Here's how we can model a feedback loop system involving a 100 Hz brainwave oscillation using a simple control systems approach. -1. Feedback loop model block diagram concept. Imagine the system. Input signal gives brain process, gives output or behavior, gives sensor, gives feedback path, gives back to input or represent it mathematically. 2. Transfer function with feedback general form for a closed loop system is HS equals frac GS1 plus GSH underscore FS, where forward path transfer function e.g. brain response model, feedback path could be a sensor or processing element, overall system transfer function, where and for 100 Hz. -3. Example, sinusoidal input at 100 Hz LETs say the input is xt equals a CDOT sin 200 pi t, and we model the brain's frequency response as a bandpass filter centered around 100 Hz. GS equals frac omega underscore 0 SS to plus omega underscore 0 Q CDOTS plus omega underscore E, where quality factor, sharpness of the frequency response assume unity feedback. Then HS equals frac GS1 plus GS. This lets us analyze resonance, phase lag, and amplitude stabilization in a feedback system like neurofeedback. Would you like me to graph this, simplify it for a non-mathematical audience, or relate it directly to neurofeedback device function? To describe a feedback loop vibrational pattern at a frequency of 100 Hz, especially in the context of brainwave or neurological oscillations, we can use a sine wave model, which is common in signal processing in neuroscience. Basic vibrational pattern equation: sine wave, yt equals a CDOT, sin 2, pi of t plus phi, where the output signal e.g. VOLT or E reading at time, amplitude strength of the wave, frequency in hertz, here 100 Hz, time in seconds, phase shift optional, 0 if not considering phase delay, plug in 100 Hz to yt equals a CDOT sin 2 pi C.100 CDOTT plus phi, or if phase shift is ignored, yt equals a CDOT sin 200 pi t. This represents a pure tone or brainwave oscillation at 100 Hz, commonly referred to in neuroscience as high gamma wave activity, typically associated with focus, memory, or intense cognitive states. If you're thinking in terms of biofeedback loops, you could model input-output relationships using differential equations or transfer functions. But for simple vibrational frequency measurement as in EEG, the sine function is appropriate. Would you like this equation adapted into a feedback system model with input-output loop dynamics, or visualized as a graph?